Welcome back. In the last video, we downloaded our pizza, steak, and sushi data and created paths to the training folder and the testing folder. So now we've got images downloaded to our file system over here. We want to turn them into PyTorch data loaders so that we can load them into a model. And we've done this before, but there's a little tidbit that we're going to have to do for using a pre-trained model for transfer learning. So let me turn this into Markdown. Oh, what have I done there? I don't want that. So now we've got some data. Let's type this out. Now we've got some data. Want to turn it into PyTorch data loaders. And to do so, we can use datasetup.py and the create data loaders function we made in 05 PyTorch going modular. So if we go back to going modular, then we had datasetup.py. So we created this file. We have datasetup.py, and there's a function in that called create data loaders. And what this took was a training directory, a testing directory, and a transform. So this is what we're going to have to pay attention to here when using a pre-trained model. And then what it would do is we use image folder to create the training data, and then we turned the data sets, the PyTorch data sets, into data loaders. And then we returned the train data loader, the test data loader, and the class names. And we used our transform here to transform any images we'd like to use from the image folder. So that's what we're going to cover in this video. If we look in here, we've got going modular, we've got datasetup.py ready to use. So create data loaders. We've already imported it, but I just want to show you, if we go from going modular, import data setup, and then we can go data setup dot create data loaders, and then what do we have here? Is this going to import? Yeah, there we go. Trained-er, tester, transform. So that's what I'd like to talk about now, is train data loader, test data loader, and class names. So recall that the transform, I'm going to write this down. There's one thing we have to think about, but there's two ways to do it. So one thing we have to think about when loading data is how to transform it. And with Torch Vision 0.13 plus, so this is why we are making sure that we're using Torch Vision 0.13 plus. There's two ways to do this. Number one is manually created transforms. And number two is automatically created transforms. So number one is manually. You define what transforms you want your data to go through. And two is the transforms for your data are defined by the model you'd like to use. Now, so we've said, how do we transform our data? And this is an important point. Important point is when using a pre-trained model, it's important that the data, including your custom data, that you pass through it is transformed in the same way that the data the model was trained on. So that's what we're going to have a look here. So we've covered a few things here, and I know they said there's one thing and then there's two things, then there's another thing, but these are kind of all the same point, is how do you, once we've got images loaded over here in data, once we've got images here, how do we get them into PyTorch data loaders? And so our function here, create data loaders, we have to define a transform. In other words, how do we transform it from images into tensors? because models like tensors, right? So what we're going to go through is step 1, manually created transforms, and then step 2, automatically created transforms. Now, this one is only introduced in 0.13 plus, which is why we emphasize the fact that we need Torch Vision 13 plus, 0.13. So if we go import Torch Vision, just make sure your version of Torch Vision is 0.13 plus. Otherwise, what we're using, so this is 0.14, we're good to go. If it's not 0.13 plus, this step 2 won't work. Let's go through step 1. So we'll create another heading here. 2.1, creating a transform for Torch Vision .models manual creation. And if I haven't introduced Torch Vision .models already, we'll just introduce it here. Torch Vision .models contains pre-trained models, so models ready for transfer learning, right within Torch Vision. So let's have a look at how we can manually create a transform. So I'll just get rid of this, and I'll get rid of this. And I don't think we need that. We might just keep that like that. Beautiful. Okay, so we'll jump into Torch Vision models. And so I'm going to look at the documentation here for 0.12. And then I'm going to go look at the newer documentation. So models and pre-trained weights. Now it's important to be aware of the older version because you probably will see this in PyTorch code you find in the wild, but eventually everything will start to move towards the newer versions. So the main transform you have to be considerate here if you're using a model for classification is, if we come down here, yeah, all pre-trained models expect input images normalized in the same way. And now this transform is for computer vision images. However, this whole premise of using transfer learning is for the same for almost any problem. You have to make sure your input data, regardless of whether it's images, text, or audio, is transformed in the same way your pre-trained model is. But since we're focused on images, we're focused on Torch Vision models and pre-trained weights. So we need this normalized transform here. What this is going to do is ensure that our data has mini batches of 3-channel red, green, blue images of shape 3, so color channels, height, width, where height and width are expected to be at least 224. The images have to be loaded to a range of 0 and 1, so their values have to be between 0 and 1. We can do that with the 2-tensor transformation. And then their pixel values have to be normalized using mean equals this list of values here. I'm not going to read them all out. And standard deviation. What this means is that our images, if we normalize them like this, will have the same data distribution as the pre-trained models. And so if you want to learn the process of obtaining these values for mean and standard deviation, they are learned from the ImageNet dataset. So if we look up ImageNet, and if you wanted to calculate the data distribution, now I did have some trouble loading this website the other day. So we'll just go to the Wikipedia version of ImageNet. Yeah, there we go, ImageNet. So the big ImageNet has 14 million images, but the smaller ImageNet has 1 million images. So this is just basically saying, format your data so that it has the same distribution. Recall what a data distribution looks like. There we go. Something like this, a curve. That's similar to a normal distribution, but these values have been calculated to be the distribution, the mean standard deviation of the ImageNet data. So we want our own custom images to have this same distribution. And now these values, there's 3 values here because it's 1 for each color channel, red, green, blue. So that's enough talking. Let's see this in action. I'm going to copy this. I'm going to bring this in here. Now you might not have this. The documentation might be different by the time you read it. So let's jump into the new version of it. And we're kind of mixing and matching a few things here, but it'll all make sense in a second. So models and pre-trained weights. This is a little bit different formatted documentation. Do we have normalize? Yeah, okay. So you're not going to find this what we just found anywhere in the new documentation. So that's why we're covering two different ways of making transforms. The first one is manual. The second one is automatic, which we're going to have a look in the next video. So let's do the manual transform first. So from Torch Vision, import transforms. That's what we want. So what we're doing here is we're formatting our own custom data to be in the same format as the models that we're about to use have been trained on. So let's go manual transforms equals transforms.compose. And if we just jump back to the older documentation, models and pre-trained weights, we're just going to copy this line in here so we know what transforms we need. All pre-trained models expect this. So we can break this apart. And any good documentation where you find pre-trained models will have this information stored somewhere. So normalize. Yeah, that'll do. Okay, so we need three kinds of transformations here. We need height and width are expected to be at least 224, and the images need to be loaded into a range of 0 to 1, and then normalized using these values. So we've got our normalized transform here. Let's now do the first one. So transforms, we're going to resize our image. So as an image comes in, it's going to get resized to 224, 224. Now you can adjust these values to be whatever you want. So say you had a model that expected images of 300, 300. So height and width of 300, 300. You can change that. The reason why I'm showing you manual transforms is that because you can customize this pipeline to however you want it. Whereas when we see the automatic transforms, they're already made for you. So the flexibility of manual transforms is that you can make them whatever you want. However, the downside is if you have errors in here, or such as you're not transforming your data in the same way as your pre-trained model, you may get performance degradation. So this is what we're doing. We've got one resize image to 224, 224. That's height times width. I've spelled that correctly. And then get images into range 0 and 1. And then make sure images have the same distribution as ImageNet, where our pre-trained models have been trained. So that is this important point. When using a pre-trained model, it's important that the data, including your custom data, that you pass through it is transformed in the same way that the model was trained on. So if we wanted to create data loaders using this manual transform, let's see what that looks like. We can go train data loader. This will be using this function here, data setup. I might just get rid of that. Train data loader, test data loader, class names equals data setup dot create data loaders. So using the function we created in the previous section, train directory is going to be equal to the train dir, and then the test dir is going to be equal to the test dir, and the transform is going to be equal to the manual transforms, what we just created above. So it's going to pass all of our images through this little sequence of transforms. And then what other things do we need here? Maybe batch size? Create data loaders, transform, batch size, yeah. Let's set a batch size of 32. And let's see what this looks like. Train data loader, test data loader, class names. Beautiful. Now we're not going to see those transforms because they're going to happen behind the scenes, but we've now transformed our data using manual transforms. In the next video, let's take a look at number 2 here, automatically created transforms. I'll see you there.